Good evening. Yesterday I could not have a nice day, and I hope you are doing well today. This day brought good tidings to you and in your academic and personal life. In the last class, I was trying to talk about protein structure and function, and I wanted to just tell you that I will again, after finishing biomolecules, I will repeat the points which are all left out. For example, remember there are molecules like chaperones. Please remember chaperones. Chaperones are responsible for facilitating the formation of tertiary or quaternary structure of a protein. Sometimes when there is a defect in the chaperone, you will have a dysfunctional protein. It could be a single polypeptide or a protein like allosteric protein like hemoglobin. For example, it is very important, again to repeat, the quaternary structure of hemoglobin is very important for its function. The contact points between alpha 1, beta 1 and alpha 2 and beta 2 crossways also are very, very important. And these contact points and this type of correct structure is helped by the presence of chaperones. And if these chaperones are not bound to a particular specific protein, which helps and facilitate the formation of the quaternary structure of a protein, that can form a dysfunctional protein. For example, one must remember hemoglobin is housed inside the RBC and it is without mitochondria, but it deals with oxygen. Oxygen is very important for our life because it is very important for oxidation, but at the same time, it can also generate free radicals like superoxide radical, hydrogen peroxide, hydroxyl radical, which are detrimental to the integrity of the structure as well as to the function. For example, the coordinate structure of heme attached to the hemoglobin helps to maintain ion atom in the ferrous state. So whenever there is a free radical, what is a free radical? A free radical is an unpaired electron. So when you are unpaired, when you have an unpaired electron, it will try to extract electron from an electron dense region. What are those regions which are electron dense region? Double bonds. Is it not? By sharing of electrons, you create double bonds. So when it picks out one electron from a double bond, what will happen? The double bond will be lost. And if it is an essential fatty acid, polyunsaturated fatty acid, which is present as a cis isomer in the plasma membrane, if the electron is extracted from that structure, naturally the plasma membrane phospholipids will be affected. At the same time, the structure also will be compromised. So that is why this free radical has to be quenched and then eliminated from the cell as well as from the organ or from the tissue, wherever they are generated in higher amounts. So that is why this coordinate structure with the presence of a proximal histidine in the F8 helps to donate an electron and keep the ion atom in ferrous state. This is helped by methemoglobin reductase enzyme. So methemoglobin reductase is responsible. What is methemoglobin? Hemoglobin, where the iron atom is in the ferric state, which cannot bind oxygen, and so naturally cyanosis will be present in these patients. So methemoglobin reductase is very important to keep the iron atom in the ferrous state. And for this to function well, the quaternary structure of the protein hemoglobin is very important, particularly the contact point alpha 1 beta 1 and alpha 2 beta 2. The cross linkages are very important to maintain its function. So if it is compromised, free radicals will be generated, and this will cause a disruption of the structure of, say, like RBC. How it can do that? You know that it can inhibit the binding of ankyrin spectrin, protein on the plasma membrane, and also it can disrupt the spectrin structure. So this will lead to deformability characteristics, as well as it will affect the hemodynamics of blood circulation. For example, the classic, you see the nature of our system. We say that miracle of a superpower or miracle of our body. So the RBC, which is having a biconcave disc because of the presence of specific proteins on its plasma membrane structure, has the capacity to modify and adapt its structure to go through a bigger vessels also and diffuse through very small narrow-meter artery holes also. And this is deformity characteristics is because of its structure and because of its plasma membrane structure. And this is, if it is affected, for example, like if the spectrin is compromised, we have spherocytosis, then echinocytes can be formed. And so there are many different disorders that can be the result of a disruption of the structure of protein that are present on the plasma membrane. And this may lead to the loss of biconcave disc shape, and that loss of biconcave disc shape will give rise to hemolysis, and the person can go into severe anemia also. So it is, see, it's a real, you start with the protein, then how it has so many functions to how its small function of oxygen carrying and oxygen releasing has to be maintained. I'm sorry. Hello? Yes, I'm in the clinic. Yes, sir. Sorry, sir. Anything urgent? Okay. I'm sorry, that was a student calling. So please remember, these are all just what I'm talking to you is the tip of the iceberg, we can say. So that is why we will talk about immunology and immunological function, this adaptive immunity, cell-mediated immunity, say when we are talking about plasma proteins. I will talk about that in greater detail. There also I will talk about anti-inflammatory markers and the related disorders associated with this. So for example, like I told you last class also, please don't forget hemoglobin H, hemoglobin BARTs, some of those disorders where, for example, if the distal histidine is replaced by some other amino acid like proline or tyrosine, the iron atom will be kept in the ferric state, and then so this type of mutations, we can say the mutations could be due to a defect in the globin structure, or it can be the product that is the protein structure as well as the defect in the gene that tries to produce the protein. So we will talk about this in our immunological functions as well as immunological memory. So that will be a very interesting talk, where I will try to talk about the molecular biological aspects of this immunology also to you. So for the time being, we can think that we have somehow managed to complete a bird's eye view of biomolecules, including proteins and amino acid structure and function. See, I am not going to delve deep into some of the other aspects. I wanted to stretch upon certain things which I want you to remember here. Whenever I am going to talk about disorders associated with defects in biomolecules, I will try to specifically talk only about those particular symptoms that are totally relevant to or related to biochemistry. For example, depression can be a common phenomenon. But for example, if the person is having a subluxation of the lens due to homocystinuria, that structural defect is because of the presence of homocystinuria. So I will be talking like that. I'm not going to give a general what you call that symptomatic, that which is supposed to be very important for clinicians when they try to come across this. So, but my job is to relate these symptoms that are concerned directly with the biochemical defect. So that I will also talk about it when I'm going to talk about the defects in this. Before we go into other details, today I want to stress upon a small discussion about vitamins, and these vitamins, particularly water-soluble vitamins to you. Why? Because water-soluble vitamins has to be taken as the first lecture following proteins and enzymes or before enzymes. There is lots of controversy whether when this topic can be dealt with. Water-soluble vitamins are so important because they have a very important function for enzymes to act. If these water-soluble vitamins, apart from vitamin C, they have coenzyme forms, and these coenzyme forms combine with the protein part of the enzyme to form the active enzyme. We call it as the hollow enzymes, and these enzymes are very, very important for the bodily functions of our body. These enzymes are those molecules that churn out metabolism. They regulate metabolism. They generate energy. They play so many important roles in our system, and so it is always essential for all of us to know the importance of vitamins in our body. So that is why some of the textbooks, standard textbooks, I'm not talking about textbooks which are catering as notes to the students, I'm talking about standard textbooks, always say that the body requires macronutrients as well as micronutrients. Macronutrients, as all of you know, are carbohydrates, fats and lipids, fats and proteins. Micronutrients are vitamins and minerals. Because this carbohydrate, whatever energy is present as potential energy in carbohydrates, if it has to be released as chemical energy, you require these micronutrients, the B complex vitamins, which will activate the enzyme that are responsible for metabolizing this molecule into smaller stepwise, so that it will be an efficient way of producing energy. Okay, that is the reason why. So water-soluble vitamins, we can just say there are different nomenclature, but the first vitamin we are always thinking about is thiamine. Thiamine is a sulfur-containing vitamin, and it is supposed to be sulfur-containing thiazole ring it has, and do not worry about the structure of this thiamine. You can see a textbook and try to understand what is the structure. The most important point about thiamine is it is having a coenzyme form. We call it as thiamine pyrophosphate, TPP we call it. And this thiamine pyrophosphate is required for activating the enzyme like pyruvate dehydrogenase, alpha ketodehydrogenase, trans ketolase, and many other enzymes. These are three are the very important enzymes. For example, like adding a carboxyl group, carboxylation reaction or decarboxylation reaction, we have removal of carboxyl is decarboxylase, adding a carboxyl group is a carboxylation reaction. So, for example, like when you are converting, say, pyruvate, the pyruvic acid molecule, into acetyl coenzyme A, it has an enzyme complex called pyruvate dehydrogenase. The first one is supposed to be, it is made up of three enzymes complex together, And then when it is, what happens is it binds with pyruvate and removes the carboxyl group. So decarboxylation reaction. For that particular reaction, it requires thiamine pyrophosphate. For example, if a person is taking lots of alcohol, then he comes with, you take an X-ray, you see enlargement of the heart, you say pericardial edema, and this is due to thiamine deficiency. Simplest thing. Why? Because when there is thiamine deficiency, what happens? The conversion of pyruvic acid to acetyl-CoA is impaired or inhibited. In the process, you have the accumulation of pyruvic acid and lactic acid. And pyruvic acid and lactic acid are supposed to be vasodilators. So that is the reason it causes pericardial edema. So you understand now how peripheral, this is very important for this. So we call this as a wet beriberi. We say that this is as a wet beriberi. Then neuritis means we call it as dry beriberi, which CNS function. Then Wernicke's encephalopathy, where the enzyme has a defective structure so that it cannot bind TPP. Then thiamine pyrophosphate is also very important for the enzyme transketolase, which is one of the key enzymes of pentose pathway you will come across. And transketolase is, see the name itself. See, for example, if you look at the word and then if you understand the word itself, you understand the biochemical mechanism very easily. What is the name of the word? Transketolase. Transfer of ketol group. Ketol means what? Alcohol means aldol. Ketol means with a C double bond O. So CH2OH C double bond O is called as ketol group, and the transfer of this requires the enzyme transketolase. And this is supposed to be a marker, that is the transketolase activity is a marker of thiamine status in our body. So this is very common sense that any green leafy vegetables are required for this. It cannot be synthesized by the body. That is why they are supposed to be vital for our functions. Funk long ago said it was supposed to be an amine structure, so that is why he called this as vital amines. So vitamins. So we need to about say milligram quantities of this vitamin in our diet every day. The most important point which you are supposed to remember here is thiamine is a sulfur containing vitamin. It has a thiazole ring. Its coenzyme form is TPP, and it is very important for the function of decarboxylation reaction, transketolase reaction, and these are, we will see during metabolism, pyruvate dehydrogenase, alpha keto dehydrogenase, transketolase are some of the reactions which are involved. When thiamine is deficient, you can have wet beriberi, dry beriberi, Wernicke encephalopathy. So that is the small amount of discussion about thiamine. Then what we have, the other vitamin which is very important is supposed to be riboflavin. Riboflavin has an isoalexazone ring. It is very important vitamin because it's a coenzyme for reactions involving oxidation simultaneously with reduction. That is, one substrate is oxidized, simultaneously another substrate is reduced. So we call these enzymes as oxidoreductases, or in other words we can say that as dehydrogenases. So that means its coenzyme form are supposed to be flamine mononucleotide. We call it as FMN. One of the questions that can be asked is flavin mononucleotide, why it is called as a pseudonucleotide. We will come across when you are talking about nucleic acids. We will talk about this. A nucleic acids nucleotide means a base, a sugar plus a phosphate together is called as a nucleotide. The sugar is supposed to be ribose. In flavin mononucleotide, instead of the ribose, it is ribitol is present. That is why it is called as a pseudonucleotide. And this FMN is very important for oxidoreduction. The most important thing here is that when you take an enzyme part, which we call it as apoenzyme, this particular FMN is attached as a prosthetic group. So oxidases will have this FMN. So this is a flavor. So it cannot be easily separated from the enzyme. It is not loosely bound. It is very tightly bound. That's why it is called as a prosthetic group. So the FMN is attached to this, and so it accepts 2 protons. Not 1 proton, it accepts 2 protons. The other coenzyme form is FAD, flavin adenine dinucleotide. And the FAD is a very important coenzyme. As a coenzyme for so many important enzymes in our body. One of them is supposed to be about succinic dehydrogenase. You will see in citric acid cycle. It's also very important for so many other enzymes. We will talk about that. So this will also accept 2 protons. For example, riboflavin is supposed to be photosensitive. That is, if you keep the riboflavin exposed to sunlight, it will be degraded. So that is why when a premature baby is kept inside an incubator, and then if it is exposed to the UV light, it will also break down apart from bilirubin. Usually neonatal jaundice baby are kept to break down the bilirubin. At that time, it will also cause deficiency of riboflavin. So riboflavin will cause stomatitis, that is, you will have a reddish lip. So that is why it is supposed to be very photosensitive. Same green leafy vegetables are supposed to be the recommended dietary source. And then recommended dietary allowance. There are so many other factors in nutrition. I want to stress upon nutrition as the last chapter of my lecture, because nowadays it has become so important for us that nutrition plays a very important role in most of the things. For example, we are now, I was surprised to listen to Dr. Shiva, the one who found out email at the age of 14 years. That was a miracle, isn't it? A man of 14-year-old boy was able to digitalize the post box into email. That is a fascinating story. That's why I put it on my Facebook page. Please go through that. And he said Siddha is a systemic medicine. And allopathic is not so. It is supposed to be Siddha is supposed to be a systemic medicine. It is like a system biology, that it deals with not one single tissue, it deals with the system itself. He said how his mother could look at the face, the facial reading. It's a science, it's called as physiognomy. I saw a book worth 2,000 pages dealing with physiognomy. She could be able to identify some of the common disorders a person can have. So naturally, these are all things which we have to see. Wherever knowledge comes, whether it comes from Siddha or anything, you can take the good points, scientific points, include in our system, and then it may help. What is my motto? Finally, to help the patient to recover, or you can say in the era of preventive medicine to personalized medicine. It's a very fantastic field now. It's opening up. We call it as personalized medicine. That is, you know the genomics of the person, and when you know the genetic makeup of a person, then you give drugs specific to his genetic constitution. So that is why this era is going to be personalized medicine. So that is why us doctors, you are supposed to be well versed in genomics also. And that era, so you combine multiple skills will help you solve out these problems. Okay, so this, I think, I'm just trying to bring out whatever points come to my mind at that particular. See, I do not want to forget certain issues, so that you keep your mind open, so that you learn. See, every time you have to learn, every day you have to learn. Whether you are an expert, whether you are starting your career, whether you are a student, everyday reading is very, very important for you. It refreshes your memory. And also, it tells you the point of view of others, what they think about this, what about, whether it is a diagnosis, whether it is a structural definition, whether it is a surgical procedure, whether it is a medicine protocol, algorithm, whatever it is, it gives you the other man's perspective. So it is always very essential for you to read. For example, I understood molecular immunology from one archives of surgical sciences. I forgot the issue's number, but that gave me a very clear picture. Why? Because their purpose is to write a review article that even a doctor could understand. They are not biochemists, isn't it? They are not immunologists, but they are prescribing physicians. They will not have much time to go through all the points, but that gives a very clear, simple explanation of molecular immunology. Like that, when you go through different journals, you will come across certain biochemical points very clearly in journals which are not related to biochemistry. So we were, sorry, we're going away from the topic. So we were talking about what? One, we were talking about thiamine, then we were talking about riboflavin. Then we are supposed to talk about nicotinic acid. That is, nicotinic acid also has, it's a water-soluble vitamin. So these are all, I don't want to stress, the water-soluble vitamins are soluble in water, they are easily excreted in the urine, so they have to be supplemented. This is common sense. See, I do not want, when somebody says water-soluble vitamins, means this must come to you in the body. It is not stored in the body. So naturally, nicotinic acid has two coenzyme forms. One is called as nicotinamide. It is not nicotinic acid. Please remember, nicotinamide adenine dinucleotide, NAD. The other one is nicotinamide adenine dinucleotide phosphate. So it has two coenzymes, NAD and NADP. Please remember this. NAD is very, very important coenzyme for those enzymes, oxidoreductases. This NAD is not tightly bound to the enzyme. It is loosely bound. It can be easily separated from that is the protein part plus the non-protein part. Together we call it as holoenzyme, isn't it? You have a coenzyme plus the coenzyme, you call it as a holoenzyme. It is supposed to be an active enzyme. So this NAD is very important for oxidoreductases. There are so many enzymes in our body which cannot function without NAD. I'll just tell you only one example, which is very unique. See the adaptation of human body. For example, if you are generating NAD captures a hydride ion, a proton and two electrons. It's called as a hydrogen atom with one proton and two electrons are called as hydride ion. And this captures, the nicotinamide part captures that in the alpha form or in the beta form. That is the placing of the hydride ion in space. It can be alpha form or in the beta form. So this capturing of this, then this presents this, it takes up the protons and that is the protons, then it gives it for oxidation in an oxidizing machinery. That machinery, what does it do? It grinds the machine, it generates heat, and that heat is responsible for coupling, say, ADP, adenosine diphosphate, with inorganic phosphate to form ATP. We call this as oxidation coupled with phosphorylation. We call it as oxidative phosphorylation. NAD is one. Classic example is this NAD, so where does this oxidative phosphorylation takes place? Inside the mitochondria, that is the inner mitochondrial membrane. RBC does not have mitochondria. Now, the glycolysis, if it has to takes place, that particular enzyme, glyceraldehyde 3-phosphate dehydrogenase, has to be active. We will see this in glycolysis, but there, what is the catch point? That the NAD has to be, which is in the NADH, which gets reduced during glycolysis, needs to be regenerated as NAD. What we would have done, we would have taken a factory, manufactured this. What will happen? Simple thing, God, what he did, he converted the pyruvic acid, the end product of the glycolysis, into lactic acid. So what happens now? The CO, that is the C double bond O carbonyl group, is converted into CHOH. That is from the NADH. So now what happens? You generate NAD, and this NAD continues to link with the glyceraldehyde 3-phosphate dehydrogenase. Then you can say glycolysis is going on. So it is such a systematic, orchestrated biochemistry that takes place in your body. And that is why NAD is very, very important for its function. So for example, when you don't have this, We say pellagra preventive factor, the dementia, dermatitis, diarrhea, all three features of this particular disorder. Let's see why it is so. Dementia, dermatitis, why it is so. It's all related to glucose, energy, and maintenance of the skin structure. So that is why it is related to that, is it not? Same way, NADP. This is for oxidation and reduction. That is for hydroxylation reaction. What do you mean by hydroxylation reaction? Adding a hydroxyl group to your substrate. So whenever you are having a hydroxylase, this can be called as a monooxygenase or dioxygenase. Don't go confused by the terminology. You require somebody to hold on that H and give it to you. And NADPH does that function. And you will see that the main purpose of this pentose pathway in RBC is to generate NADPH, which is very important for reduction reaction. So naturally I told you about niacin, NAD and NADP. Then I told you about its functions. And also I just very clearly told you about pellagra preventive factor, diarrhea, dementia, dermatitis are the features. And that is why we have a same thing, green leaf vegetables, whatever you are having, please eat that. Sometimes what happens, I tell you, when you have this sprouted beans, that is, take beans, put it in the water, in a cup. So in the morning you will see it will be sprouting. Eat them. That is, it produces a very good source of vitamins to your system. And so it is on less than 30 milligrams, I think. So that is the reason why NAD and niacin is also very, very important. So today we have seen riboflavin, we have thiamine, riboflavin and niacin. What else is very, very important? We have biotin, then you have pyridoxine, then pantothenic acid, then B12, vitamin C. So one more vitamin I will talk, and then I will stop, so that I will give you something to think about. Think differently. And just think out of the box. Okay, always think out of the box, so that who may know, you may hit upon some idea which may convert you into a great person. I'm not saying great means in the world, something you may find out very new also about this vitamins and its function, particularly related to its structure. The other vitamin which you are supposed to talk is biotin. It's also a sulfur-containing vitamin. So its coenzyme form, we call it as carboxybiotin. Please remember this. This is very, very important. Biotin, sulfur-containing vitamin. Its coenzyme form is carboxybiotin. It requires ATP activation to add the carboxyl group to biotin, so that carboxybiotin is formed. So then immediately you must know carboxybiotin means what it will do. It is very essential for carboxylation reaction, adding carboxyl group to substrate, like it is important in gluconeogenesis. It's because it's so important for gluconeogenesis that we will say where what is happening, formation of glucose from non-carbohydrate sources. We will see that it's gluconeogenesis. For example, you are trying to convert, say, succinyl, succinic acid, pyruvate carboxylase. You are adding a carboxyl group to pyruvic acid. You will have succinic acid. We will talk about this. I do not want to confuse it because I'm rushing through. I don't want to do that. The most important thing here is avidin is called as the egg injury factor. When you take lots of whites of the egg contains a protein called avidin, and this avidin binds to biotin, then it makes it unavailable for its absorption. This property is made use of in technology. Biotinylated proteins with avidin plays a very important role in some of the enzyme immunoassays. Please always remember, Because of technology only, the importance of biochemistry has come to limelight. You had a calorimeter. Calorimeter was able to measure the color. The color was proportional to the concentration of a substance in the blood. So any substance that is present in milligram quantities was measured by calorimeter. Then you were able to establish what is the normal levels of various parameters that are present in a normal blood glucose or lipids, whatever it is, because of calorimetry. So there was variation of calorimetry to make the techniques sophisticated and also to put it in automation. Then but the same principle was applied to make it from the manual to an automated issue. Same way, when the parameters are present in microgram levels, without the technology, you would not have known the importance of some of the biomolecules. Atomic absorption spectrophotometer came into being, and also enzyme immunoassay came into being. That is why you are able to measure some of the hormones which are present in microgram quantities, and so its decrease or increase in the blood acted as biomarkers to reflect whether this is related to hypofunctioning or hyperfunctioning of a particular endocrine gland. And this is because of the technology. Please remember that. So that is the reason why. So as technology develops, you unravel the biochemical knowledge of the molecules that are present in your system. Now what they are doing, they are trying to map this, they are going to have a 3D printing, all this technology is there. But still, nature cannot be defined by human mind because it has its own limitation. Always remember, limitations of the human mind is always there. If you could accept that, little learning is always a dangerous thing. When we think our knowledge is very less, we become very humble. When we become very humble, we pray to God, please try to enlighten us with more knowledge. Whether it is going to treat a patient with a condition which you are not able to arrive at a particular diagnosis or a particular therapy, if you sit, we call it as reflective medicine, isn't it? You reflect on what you have done during the past day. What are the patients you have seen? Which patients required your immediate attention? What is its problem? What I have done today, is it right? Is it correct? Or whether my knowledge was adequate enough to treat the patient? Did I satisfy the person, what you call psychologically, biologically, medically, surgically? We call it as reflective thinking, isn't it? Nowadays it is very, very essential for all of us to reflect upon our own actions, so that gives you to think about what you have been doing during this past day, so that tomorrow will be a better day for us. And then it gives you clairvoyance, a clear thinking. Clairvoyance is very important. You need to have a clear thinking, a clear mind. What is that clear mind? You can have any aids. The medical education says you have all the aids that is. So you have to have a visual stimuli, you have an audio stimuli, but knowledge is very, very important. Your knowledge base has to be strong. That only, with that your knowledge base, you can use all this technology to help you out. And important thing, please remember, human touch, human concern, human love every day before you leave, because you are having a very busy day dealing with the patients. But a smile from you or a tap on the shoulder calms down, like a yogic calming down. His blood pressure comes down, anxiety comes down, biochemical parameters, they get normalized at that particular moment. Apart from all your gadgets, this human touch of yours definitely takes care of the human person. You are all very good human person, and biochemistry teaches you to be a very good human person. And so I will try to continue the next lecture tomorrow. Continue with the what are the vitamins that are left out. Then I will try to talk about the relations to certain disorders. Then I will go for enzymes. Thank you very much for your kind listening. Bear with me. My pronunciation, sometimes, I have a problem. Some of my words, and I have this some cough. Sometimes I'm interfering it. But I have a satisfaction of talking to you directly. I feel I am seeing you in person. I feel your presence. I feel your love. I feel your affection. I feel your attention. And I feel very happy once I talk. That is the purpose of my life. There is nothing else. Why? Because all other actions, all are personalized, selfish, self-oriented, including myself. I am not an angel. I am also a human being with lots of defects and problems. So many problems I have, so many mistakes I have done in my life, so many mistakes I'm still doing. But yet, this talk refines me, purifies me, takes me to a higher plane of thinking. Why? Because I think about you. So I go in my thinking. My prayer is telling you some facts which I know from biochemistry to you. That is my prayer. That is my slogan. That is my ayat. That is my psalm. So that let my God help all of you. Have a nice day. Thank you very much. Good night.